All right, so we really didn't talk about compound inequalities too much because it's its own section. So 2.5, compound inequalities. Compound together. So find the intersection of two sets. The solution set of a compound inequality formed with and is the intersection of the solution sets of two inequalities. So the intersection of sets, A and B, is the set of elements common to both sets A intersect B, and it's denoted A upside down U, B. So that part, that's the intersection. Right, you know Venn diagrams, so let's apply that to math. Let's find the intersection of 2, 4, 6, 8, 3, 4, 5, 6. So basically the intersection is what they have in common. So they have 4 in common, they have 6 in common, and that's it. So the intersection is 4 and 6. Solving compound inequalities containing and. So this is a compound inequality because we're given two inequality signs. So we have 0 is less than or equal to 4 times 5 minus x is less than 8. We're going to graph the solution set and express the solution in interval notation. So we just have to solve for x. So we have two problems here. We have a left side. So we have 0 is less than or equal to 4 times 5 minus x. And then we have a right side. So 4 times 5 minus x is less than 8. So the middle goes to both sides because it's sharing. So it goes to the left and it goes to the right. And from here, we just solve for x for both of them. For our green one, we're going to distribute 4. We have 0 is less than 20 minus 4x. We're going to subtract 20 over. My bad. Add 4x over. What am I talking about? So we have 4x is less than or equal to 20. Divide by 4. So we get x is less than or equal to 5. Now we need to do the same thing with the purple one. So we distribute by 4. We have 20 minus 4x is less than 8. Go ahead and subtract 20 to both sides. So we have negative 4x is less than negative 12. Divide by negative 4. And since we divided by a negative, we have to flip the sign. So we get positive 3. Now, since this is a compound inequality, we're just going to put them together in numerical order with a comma. So we have 3, comma, 5. Now, with the 5, it has a line underneath, so bracket. With the 3, there is no line underneath, so parenthesis. To graph our solution set, since they go together, we just put our two numbers. We have 3, we have 5. The 3 has a parenthesis, the 5 has a bracket, and since this is compound, they go together. All right, example 3. Let's go ahead and get rid of this, all these fractions. So our common denominator is 3 times 5, which is 15. So we're going to multiply everything by 15 over 1. So we have 15 over 1 times negative 2 over 3 is less than, just less than, 15 over 1 times 6x over 5. And that's less than 15 times 1. There's no fraction, so we don't need to put it over the 15 over 1. All right, so 15 divided by 3, we're left with 5. 15 divided by 5, we're left with 3. And 15 times 1 is just 15. So what we're left with is 5 times 2 is 10. And that's less than 3 times 6x is 18x. And that's less than 15 times 1, or 15. Now we're going to break it up into two. So our first one is the left side. So our left side is 10 is less than 18x. And then our right side is 18x is less than 15. So for our green one, let's go ahead and divide by 18. So we have to simplify, remember, because those are both even. So divide by 2. So 10 divided by 2 is 5. 9 divided by 2 is 9. 18 divided by 2 is 9. Sorry, that's negative 10. There's a negative there. Negative 10. Negative 5 over 9. And that's less than or equal to, or just less than x. My brain keeps wanting to say less than or equal to. Now, we like to keep x on the left. So I'm going to show you how to rewrite that over here. So what I like to do is draw Pac-Man. So you see how Pac-Man's eating X? So when I rewrite it, I need to make sure Pac-Man is still eating X. So if I look back, Pac-Man's eating X. So we're good. It's the same. It just rewrote it so the X is on the left. Now for our purple one, I'm going to move that where I have more space. We're going to divide by 18. And we have 15 over 8. So 15 over 8, we can divide each of those by 3. So we'll have 5 over 6. Now, since this is a compound inequality, they're always going to go together. If they start together, they end together. So our two numbers in numerical order is negative 5 over 9 and 5 over 6. With the 5 over 9, there is no line underneath, so parenthesis. With the 5 over 6, there is no line underneath, so parenthesis. Finding the union of two sets. The solution set of a compound inequality formed with OR is the union of the individual solution sets. So the union of two sets is A, U, B, so it's all together, because union means together, right? When you unionize something, you come together. So example 4, let's find the union of 2, 4, 6, 8 and 3, 4, 5, 6. And I know it's union because of the U symbol. So union means bring together. So I'm just going to write all the numbers together. And remember, we never write things twice. So if there's two numbers, just write it once. So we have 2, 3, 4, 5, 6, and 8. And there's our union. All right, let's go ahead and example 5 and solve for these two inequalities. 5 times x minus 1 is greater than or equal to negative 5, or 5 minus x is less than 11. So let's just take it piece by piece. We're going to distribute 5, so we have 5x minus 5 is greater than or equal to negative 5. Add 5 to both sides, so we get 5x is greater than or equal to 0. Anytime anything is greater than or equal to 0, it's just 0. So we have x is greater than or equal to 0. Now we do our second one. So our second one, I'm going to subtract 5 to both sides. And when we do, we're left with negative x is less than or equal to 6. And we're not allowed to have that negative, so we're going to multiply it out. And we have x is greater than or equal to negative 6. Now, we should graph this, because how do we know how to write it in interval notation? This is not a compound inequality. It didn't start together. It has the word or. It didn't start together. It's already separated. Since it's separated, we need to graph this in order to figure out how to write this in interval notation. So we have our two numbers, 0 and negative 6. So for 0, it's bracket to the right, because it's pointing to the right. For negative 6, my bad, I put that in the wrong space. Negative 6. For negative 6, it's bracket, and it's pointing to the right. So you see how they're both pointing in the same direction? So now we need to put it together. So the whole thing starts at negative 6 and goes to the right, which is positive infinity. All right, example 6. We have negative 2x minus 5 is less than negative 2, or 6x is less than 0. So this is not compound. It did not start together. All right, so for our first one, I'm going to add 5 to both sides. And when we do, we have negative 2x is less than 3. Divide by negative 2. So since we divided by a negative, don't forget to switch the sign. So we have negative 3 over 2. Now for our second one, we have 6x is less than 0, so x is less than 0. You can divide by 6, it just comes out to 0. So now we need to figure out how this looks because of the or, and how do we answer in interval notation. So we have our number line, we have our two numbers, negative 3 over 2 and 0. So for 0, it's parenthesis pointing to the left. And for negative 3 over 2, it's parenthesis pointing to the right. Now you're like, but they go together. This is compound. Nope. This is a special answer. Because it says or, if they go all the way to the left and all the way to the right, you see how they do here? They pass each other in opposite directions. That's negative infinity to positive infinity, meaning you can plug in any number and it'll work for one of them. All right, example 7. Brandy Max is polling 80, 90, 82, and 75. Find the range of her polling scores she can have to be polling at an average of 80 to 89. These are typical like ones where you have like grades and test scores, but I hate using those examples, so I just changed the scenario. All right, so we need to know the average of her polling between 80 and 89. Between implies compound inequality. So compound inequality is less than, and we're going to put the end equal to because she can poll between 80 and 89. So 80 and 89. Now all we need to do is figure out what the heck goes in the middle. Her polling. So she's polling at an 80, a 90, an 82, and a 75. We want to know if she takes one more poll, what's it going to be? So plus x, we don't know it yet. So that's divided by how many polls they took, and it's 5. So let's add all our like terms. We have 80 is less than or equal to 80 plus 90 plus 82 plus 75 is 327. Plus x over 5 is less than or equal to 89. All right, now we need to separate it. So for our first one, our left side, we have 80 is less than or equal to 327 plus x over 5. And then our second one is 327 plus x over 5 is less than or equal to 89. So let's get rid of the fraction. We're going to multiply both sides by 5 over 1. All that does is cancel out the fraction. So 80 times 5, we get 400. And that's less than or equal to 327 plus x. So we need to subtract by 327. And when we do, we get 73. Don't worry about rewriting it because it's compound. When it's compound, you know they go together, so it doesn't matter what it looks like. All right, same thing to the right side. We're going to multiply by 5. So we have 327 plus x over 5, my bad, is less than or equal to 89 times 5, which is 445. So subtract 327. We get x is less than or equal to 118. So if we put this back into here with what x is, so we have 73 is less than or equal to x, and that's less than or equal to 118. So what this means, she needs to poll above a 73. So she must poll above a 73. Because if she polls above, she'll get that average of being between 80 and 89. So if she polls above a 73, she will get a poll between 80 and 89.